Hey guys, I want to go over the video that we did in class today. For whatever reason, the audio did not record, so I'm going to just run through the notes. That way there's a digital version online, but it's not going to be a full-length 20-minute lecture like it was in class. So 2.1 is basic of functions. First thing we did is we defined a relation. A relation is any set of ordered pairs, the first of which is an element of the domain, also known as the input values, or commonly known as the x values of an ordered pair, and the second is an element of the range, or the output values, also known as the y values of an ordered pair. Find the domain and range of this set of ordered pairs, 2, 6, 3, 8, negative 2, 4, and 5, 6. The domain is the inputs, or the x values. So the domain is the set of numbers 2, 3, negative 2, and 5. And the range is the set of y values. And we see we have a 4, we have a 6, and we have an 8. 6 is listed twice, but we do not need to list it twice when we write the range. Now, in terms of a function is a specific type of relation where every input value, every x value, or domain value, has exactly, or at most, one output value. So, we've already went over this, but decide if each represents a function. These are a couple examples of maps. This one, 1 gets sent to 4, 2 gets sent to 5, 3 gets sent to 5. So every single one of these inputs go to exactly one y value, therefore that is a function. Example 2 here is not a function because if I say, if 1's the input, what is the output, there are 2 different output values. Therefore that is not a function. We went down through here and then we also did an example in table format. 1 gets sent to 2, also 1 gets sent to 6. So the input 1 has 2 different output values, therefore that is not a function. And then we went over how to tell if it's a function graphically. Using the vertical line test, guys, we went over this last year. The vertical line test is at any point in time you draw a vertical line and it crosses the picture, crosses the graph of the relation in more than one spot, therefore it is not a function. So if we look here, this is a parabola. No matter where you draw a vertical line, this one, the vertical line will never cross this parabola more than once, so it's a function, whereas this one is not a function, because if we draw a vertical line here, it crosses twice. Then we went over something we didn't go over last year, which is how to tell if it's a function algebraically. When a relation has the y variable isolated, the result is but one solution for y. So we did a couple of examples. X plus y is equal to 7. We would isolate the y by subtracting the x over. We get 7 minus x. Y is equal to 7 minus x. No matter what you put in for x, you only get one answer for y. Therefore, this is a function. And then we went over, if you could punch this in the calculator, we would do 7 minus x and hit graph, and we can see by the vertical line test, it is also a function. Now the second one we did was x squared plus y squared is equal to 16. To isolate the y, we would subtract the x squared over. To get rid of the square, we would square root. And when we square root, we get positive or negative, which means we have 2 different answers. We have a positive answer and a negative answer. Since it has 2 solutions, that means that will not be a function. Now, if we go to graph this, we have to graph. We got to do the square root of 16 minus x squared, and we also need to graph the negative of the square root of 16 minus x squared. And when we hit graph, we'll see that this, in fact, the picture is kind of skewing a little bit, but it's actually the graph of a circle. And it's very easy to see that this does not pass the vertical line test, therefore this is not a function. Now what causes us to have the positive negative is the fact that there's a square attached to the y. And something to make note of is, more specifically, if the relation contains an even power of y, it is not a function. So it's not just a square, but if it's any even power of y, that makes it not a function. So for an example, x plus y to the 4th equals 28, that's not a function because this y has a power of 4. Another example would be, let's say we had x plus y to the 3rd equals 10. This is a function because the power of y is 3, and 3 is not an even number. That's a shortcut way to tell algebraically if it is or is not a function. We then went over function notation. We talked about, function notation, y is now known as f of x. What's inside the parentheses is the input, and what it equals is the output. We went over how to read it, and then we did an example graphically and algebraically. Algebraically, given f of x is equal to x squared plus 3x minus 8. Find f of negative 2. That just means we take negative 2 and plug it into the function because it's our input. And when we plug it into the function and we square and then times by 3 and subtract 8, we get negative 10. I showed how to do this in class using the calculator. I'm not going to show in this video. You had to be in class to see that. Number 2, find f of x plus 2. Cannot use a calculator for this one. We still go to the function and we plug in the input x plus 2. X plus 2 squared has to be FOILed out, so it's x plus 2 times x plus 2, and then you FOIL, and we get this. 3 times x plus 2 is 3x plus 6, because you got to distribute the 3 in, and then minus 8, and when you combine like terms, you get x squared plus 7x plus 2. We finally did the last example algebraic rule was f of negative x. Plugging negative x in everywhere you see an x, so we got negative x squared. Well, negative x times negative x makes just a positive x squared, whereas 3 times negative x makes a negative 3x minus 8, and then that's a simplified version. And then we went over how to read functions graphically. So I have this drawn graph, and over here, number 1, f of negative 2. Well, negative 2 is the x. So if you go to the x-axis and find negative 2, and go down to the ordered pair that exists at that point, the corresponding y value is negative 3. Therefore, that's the answer. If I ask you what's f of 4, when x is 1, 2, 3, 4, the y value is 2. f of 3, why do I have it does not exist here? Well, when you go to 1, 2, 3 on the x-axis, there is no corresponding y value. Therefore, there is no solution to that problem. Now, how do we know f of 10 is 2? Well, we don't have 10 tick marks on the x-axis, but we do have that this arrow implies that forever to the right, it's a horizontal line. Therefore, everything to the right of 4 will have the same value as 4. And we know f of 4 is 2 because we did it earlier, so therefore the answer is 2. And then we got to this.